So let's do the partial fraction for this f of s. So now we need to do a over s plus b over s squared plus cs plus d over s squared minus 6s plus 14. And s squared minus 6s plus 14 is not factorable. If you type that coefficient in your calculator, it'll give you the roots are complex numbers. So what we need to do the complete square so that we can find the right match for the inverse Laplace transform that will give us sine and cosine. This equals, for the denominator, originally we have s squared times s squared 6s plus 14. Now for 8 terms, what am I missing? I already have s for a. And when you look at this denominator, it is s squared times s squared minus 6s plus 14. Therefore, I'm missing s times s squared minus 6s plus 14. We don't want to multiply 8 times s squared because I already have s at the denominator. We need to divide s from the common denominator. That's something I'm missing for the term a. For b, what is missing from here? That is just s squared minus 6s plus 14. And then cs plus d, I have s squared minus 6s plus 14. I'm missing just s squared. For the numerator, let's compare numerator to numerator. So let's find the s cubed terms. We have cube terms here, a and c. Therefore, we have a plus c, and we don't have cube term in original equation, so we need to let that equal to 0. Let's do the s squared terms. For s squared term, we have a times 6s, and then b times s squared, and then d times s squared. Therefore, we have a negative 6a plus b plus d equals to 0. And then s terms, we have as times 14, that's the s term, and then b times negative 6, and then there's no s term in the third. Therefore, our s term is going to be 14a minus 6b equals to 11. That's what we have in the s term. And then constant term as to the power of 0 term, we have a 14b, that's the only one, 14b, that equals to 7. Now you use your calculator. There are 4 equations and 4 unknown, and we get a equals to 1, b equals to 1 over 2, c equals to negative 1, d equals 11 over 2.
That means we have f of s can be rewritten as 1 over s plus 1 over 2 times 1 over s squared plus negative s plus 11 over 2 over s squared minus 6s plus 14.
That equals the first 2 terms we can easily find inverse Laplace transform pairs, but the third term we need to work on a little bit more. So I'm going to copy this down one more time, and then we're going to take out negative 1 out, s squared minus 6s plus 9. That's complete square term. We add plus 9, so we're going to subtract 9. And then numerator s minus 11 over 2. And that equals 1 over s plus 1 over 2 times 1 over s squared minus s minus 3 squared, that's the complete square, plus 5. I'm going to write as a square root of 5 square. And then numerator, since I have s minus 3 at the denominator, I'm going to make s minus 3. And then we need to add 3 so that we can keep that equal sign. Equals 1 over s plus 1 over 2 times 1 over s squared minus. Now we're going to separate this. I have s minus 3 over s minus 3 squared plus square root of 5 squared. And then 3 is 6 over 2. So we end up getting negative 5 over 2. The first term for is cosine s minus 3, s minus 3. However, the second, for the sine, we need to match with k value. So what we can do, we can multiply square root of 5 at the numerator, square root of 5 at the denominator. Then now we can take the inverse Laplace transform from here. That is f of t equals 1 plus 1 over 2t. Now we have a minus. The first term is cosine. Okay? For the Laplace transform of cosine kt, that is s over s squared plus k squared. So in here, we're going to have cosine. What is the value of k? Square root of 5t times translation theorem, e to the 3t. So that will take care of s minus 3, negative 5 over 2 times 1 over square root of 5. We're going to use square root of 5 for the numerator. That will give us sine square root of 5t, and we still have that translation theorem s minus 3, so we need to multiply e to the 3t. So this is the final answer.